But I think we started a little bit earlier, so it should be fine. Thank you.
Thank you, sir. The session is open for discussion. Participants can post their queries in the chat box.
So I can go to chat box. Okay, let's see. Okay, let me see.
Thank you. Excellent presentation.
Thank you.
Yeah, sure. I am the secretary of the college. Thank you very much for accepting our invitation and delivering the inaugural address. Excellent work, great work done by you. Hats off to you and your team.
Thank you very much.
Please visit our institution, sir. We extend our invitation to you whenever it is convenient for you. Please visit our institution.
I know Coimbatore weather is so good. I wanted to come maybe next time when all the COVID is kind of under control. Right now I did not travel to India for about after 2019. I did not travel. So hopefully this year.
And the months you can come over, sir. You can plan for a visit. Things will become normal. Please do visit our institution. Thanks a lot, sir.
Thank you. So anybody has questions? I'm not seeing the chat box. Let me see. Okay, I see now.
Professor?
Anybody questions? Let me see. Nice
Yes,
presentation.
Professor?
Yes.
Myself, Annamalai Sendilkumar from VIT University, Vellore.
Okay.
Professor, yes, it's a very nice presentation, Professor. I think really it's more informative to the student. You started with the very fundamental aspects and covered the latest information. Really wonderful. I appreciate your excellent work done in the past 20-25 years in this lithium-ion battery. Really very much appreciable, Professor. Professor, I have one question. Because you are concluding that no sodium and sulfur-based systems are the best for futuristic point of view. But in concern with the sulfur, because no in sulfur in electrochemistry, people know they're selling this. No, there's a surface poisoning system. Sulfur, because of this various allotropes, and it can mingle with the electrodes easily and poison the surface. But really, I'm a bit confused how this sulfur is be chosen as a best system for this lithium-ion. Sorry, the battery systems.
So the poisoning is a problem in fuel cell, for example, because if you have catalyst.
Okay.
If you have sulfur species, if that goes and sits on the catalyst surface, your catalytic site is not available for your fuel oxidation or oxygen reduction, for example.
Yes, yes.
So there it is a problem. Trace amount will kill.
Okay.
Here it is a bulk phenomenon.
Okay.
Sulfur is an electrode, bulk phenomenon. It is sitting there, but the problem is, like I said, sulfur dissolves.
Okay.
As polysulfide goes to the other electrode. That is the problem. That, if you want, you can call it as poison, but that is slowly getting better and better, more and more improvement. So it takes time, right, to develop research and development, but not like in the fuel cell now.
Okay. But for the sulfur is getting into several allotropic forms, is very easily. So you think, if you go for charge discharging?
No, they don't change. It doesn't change. It goes back to SC8. You can do X-ray diffraction. Okay. After discharge, you will see Li2S in the X-ray diffraction. When you charge it back, you will see the regular sulfur SC8.
Okay. Thanks for your answer.
They go back and forth. Yeah.
Thank you very much, Professor.
But sulfur has many more problems. It's
yes,
not
sir, yes.
life.
Yes. But yes.
But it is abundant. You do not have to mine.
Yes.
Cobalt is mined in the Central Africa.
Yes.
Democratic Republic of Congo. Lot of child labor, air pollution is a big concern.
Yes.
So mining is not going to be good. I mean, I didn't mention this recycling. That's very important.
Yes.
Actually, India probably can do recycling.
Yes, sir. Yes.
That is a good thing because you have to develop some process. But the key is this.
Okay.
When you recycle, your process has to be sustainable, affordable, cost effective, and environmentally safe. Right?
Yeah, that's very important.
You don't want to claim that I'm recycling and if the cost is more than mining, it's not going to go anywhere.
Yes.
And during recycling, if you create more pollution than using the petrol, it does not go anywhere. So that's the key. That's the important thing. So people have to develop more safer, environmentally safe processes. If it is, I think that's a good thing for India to do.
Yes, sir. Yes, certainly, sir. Okay. I appreciate for your kind words, sir. Thank you very much, sir.
Thank you.
Good afternoon, Professor. This is Arun Kumar from Tohoku University, Japan.
Yes, nice to see you.
Yeah, thank you so much, Professor. Actually, I want to know about the polysulfide shuttling in case of sodium sulfur batteries. How you overcome the issue in case of sodium sulfur batteries?
So let me see. I have to share the screen again. Let me see. Are you able to see the screen still?
Yeah.
Okay. I didn't go through this because you work on batteries. You will know a lot of things, but others do not. So I didn't go through. Let me see. See, we use localized high concentration electrolyte. The electrolyte formulation is written in the previous one here. And you can look at this paper. I should have put the volume number and page number. I didn't put it. I used the old slide. So it is already out, JAX. So you can look at it. So when we use this electrolyte, what happens is this is in situ X-ray diffraction. We start with alpha SC8, right?
Yeah.
Initially, it forms this polysulfide. First discharge, then first you see polysulfide formation. First discharge, then you charge it. Then if you go to second discharge, second charge, no more polysulfide we see. Somehow this electrolyte is forming SF containing species and sodium fluoride species on both sides. So it stabilizes on both on the sulfur side as well as on the sodium side. So that's the key. Because of that, it does not seem to dissolve and form polysulfide. It seems to go through some kind of a quasi-solid state reaction. So polysulfide shuttle is very much prevented. You see the cyclability here. Amazing. Yeah. Nobody has this. Nobody has this, I can tell you.
Okay.
And there is a big oil company interested to fund us this, but I'm reluctant. I don't want to tell the company name. I don't want to accept their money because they're a very aggressive company.
Okay.
So because it's very, very sustainable, sodium sustainable, sulfur sustainable, but more work to be done. I mean, it's still very far away, but at least tells us something.
Yeah. Thank you, Professor. So can you tell me about the feasibility of developing all solid state lithium and lithium batteries? So
all solid state lithium battery everybody wants to do, but I mentioned the problem, right? There is a lot of progress happening. The interfacial charge transfer is still an issue.
Yeah.
Large area manufacturing is still an issue. The sulfide electrolyte is better, but it has instability problems in contact with the cathode and anode. Cathode solid electrolyte interface is a big problem. Everybody is trying to work on the sodium side and the lithium side because they are a little bit softer. It's okay, cathode. If you go to high nickel cathode, what do? Toyota is wants to do, but remember, Toyota is still doing graphite.
Yes.
Yeah, so that tells you the serious challenge. So, I mean, we do work on all solid state batteries, but it is very challenging. It's not ready for prime time yet, although a lot of startups have a lot of noise sometimes, but I think it will take time. We have to wait and see how it comes out.
Yeah. Thank you, Professor.
Yeah, thank you. Any other questions? Okay.
Thank you, sir, for sharing your expertise in this session.
Thank you. It's a pleasure. And I wish you all a good conference 2 days.
Thank you.
It's already 11:15, so I will not be awake. And I have to go to work 8 o'clock tomorrow morning.
Thank you very much, sir.
Thank you.
We now request Dr. P. Meena to deliver the vote of thanks. Ma'am, please.
respected chief guest of the function, Professor Armugam Mandiram, faculty members, research scholars, and participants from various institutions, it's my pleasant privilege to propose the vote of thanks. I sincerely thank Professor Armugam Mandiram for accepting our invitation and for making it possible to be here in the midst of his busy schedule. I place on record my deep sense of gratitude to our managing trustee, Sri G. Rangaswamy, and our chairperson, Srimati R. Nandini, for their keen interest and encouragement in all our activities. Our secretary, Dr. N. Yashoda Devi, is a constant source of inspiration in all our endeavors, big or small. I express my heartfelt thanks to her for presiding over this function. I thank our principal, Dr. S. Nirmala, for her kind support and encouragement, which go a long way in the successful accomplishment of all our programs. I thank the deans and also Professor Balasubramaniam and Dr. Sadasivam and the faculty members from other departments for responding to our invitation and gracing the occasion with their presence. I record my sense of appreciation for the participants for the interest. I would be failing in my duty if I do not express my heartfelt thanks, which are due to the team of my very motivated and dedicated colleagues, the faculty members of the physics department. I thank our non-teaching staff for their technical assistance and timely help. I also extend my deep sense of gratitude to our dear research scholars who have sincerely volunteered and raised to the occasion. I wish all the participants a useful, interesting, and interactive time again. Thank you, one and all.
Thank you, ma'am. Due to unavoidable reasons, it is unfortunate that our speaker for the keynote address, Professor Sabu Thomas, Vice Chancellor, Mahatma Gandhi University, Kottayam, is not here today. So with this, we've come to the end of the inaugural session. We will have our first technical session at 11:20 a.m. Thank you.